welcome to a new composing visual music tutorial. In this episode, I want to take advantage of the newly released package GL3, and in particular this patch that you see here, the point lights patch. So you should go ahead, if you haven't done so, and install the GL3 package, follow these instructions. In the credits, you have seen how there are multiple transparent spheres and objects that are moving around and creating some interesting illumination around the spheres. So in this tutorial, I'm gonna make a simplified version of that. Easiest way to create an object like a sphere in Jitter is by creating a JitGL grid shape. But there is another way, which is the way we're going to use in this tutorial, which is to create a mesh. Let's give it an attribute as points, and then I'm going to send in a matrix through a JitGen. So a JitGen allows me to draw a sphere by creating a sphere object inside its window, and I need to feed the normalized coordinate of the incoming matrix. So the dimensions of the matrix will determine how many points in the sphere. So the sphere is now drawn as points. But I don't have any informations in terms of lighting, coloring, or other features. But inside the JitGen, I can actually extract those lighting information of using the second outlet of the sphere object. So this is interesting here because what's coming out of here is vectors that are perpendicular to each one of the points that are being output from the left outlet. So for each point, I will have a vector that is perpendicular to it. So I will have one vector here and its perpendicular vector here. So that's interesting for us because we can actually use that as a directional vector to derive the motion of objects that are bouncing on the sphere. So if I want objects to hit the sphere at a perpendicular angle, no matter where that point is on the sphere, I can actually use this information to derive some sort of motion. So in this case, I reduced the number of points of the sphere to make clear what the normals are. So here I am summing the points on the sphere to its normals. So to its the vectors that are perpendicular to each point in the sphere. The JIT multiplex is just to add a 0 point to each point of the sphere so that the vectors are drawn from the outside to the center of the sphere. So the way we're going to draw our envelopes is by multiplying the normals for a certain value, and that value will be the amplitude of my sound, and that will create a motion of objects that are will go in closer to the sphere or further away. And if we add some easing functions so that we can produce like a nice bouncing motion. What we can do instead of using normalized coordinates for the sphere is to use dynamic coordinates that move around and produce spherical motion around the sphere. So in this case, I'm using two Gitmo objects, Gitmo Perlin, so to produce some pseudo-random motion. So I created this little abstraction here where
I can generate Cellular Automata. And I'm gonna save this in a matrix here that I named CA. And then I'm gonna use this matrix somewhere else, where I'm going to send it to a matrix, another matrix, and I'm gonna extract a submatrix with dimension 110, so that's one column, and then I'm gonna transpose this to make it into a row, and then I'm gonna give it some sliding value, so it won't be going from one to the other right away, but it will have some fade out afterwards. So you can see now how these objects are being drawn to the sphere whenever a trigger happens. I can actually use this same matrix to generate some envelopes in the MSP world. And to do that, I'm just iterating the matrix. So this is outputting 10 values per frame. I'm using the iteration index +1 because the jitter index is from 0. So now I can do a simple I can use a simple MC cycle to generate sine waves and use MC sig to have an harmonic series based on a fundamental frequency. The rest of the patch is copied and pasted from the example of the GL3, the multiple lights example that I showed at the beginning, with a difference. Which is, so I am using the output of my position for the objects to be fed into the first JIT-GL buffer that will control the position of the lights. The second JIT-GL buffer is just being fed a JIT noise, so some random colors for each one of the lights. But as you can see here, I have not one but two JIT-GL mesh, and that creates the transparency effect, so that I can see objects both in the front and in the back of the sphere. So in fact, I'm creating two different spheres. One, which is the front sphere, that has I'm only drawing the front of the sphere, and that it's made clear by the attribute colface2, which means that I'm not drawing the back of the sphere, and then I have the back, in which I'm only drawing the back. Here I have a colface1, which means that the front of the sphere is not drawn.